At this point, I have downloaded my zip file of the Highland demo, and I have unzipped it onto a drive. In my case, it's D. If you're working on campus, it would be your U drive. If you're on your own computer, it might be your C documents. I'm going to create a new project, and I'm going to call it Highland demo. And in this, I'm going to say that I want it here in my D drive and Highland demo, that folder. I don't need to double click it. Remember, I can just single click it and say, okay. I don't need to create a new folder because it already is in a folder. I'm going to say, okay. It's going to create my project. It's going to create a new geodatabase. And in this case, I may want to change my home geodatabase to the one that's inside the folder that we've provided you. So let's start there by getting our data kind of organized. Inside of this, we have the Highland demo geodatabase, which is the one that we just created. What I'm going to do is add a geodatabase, and I'm going to locate it where I downloaded it. So inside of my Highland demo folder, and then I'm going to grab that Highland geodatabase. I'm going to say, okay. Now, in this case, if I wanted to, I could right click and make this my default for this project. And so that way, anything that I output will go into that particular geodatabase. I don't have to do that, but that if you're trying to keep your data together, that's one way to do it. All right. And then you can delete this particular geodatabase, which is kind of interesting to think about, that you can create a new one and then not use it and delete it out. That's the one that doesn't have any data in it. All right, so let's investigate our Highland geodatabase. Inside of that, we have our Highland DAEM, our Highland DSM, and our Highland DTM. We have something called Highland non-ground. We have a study area, and then we have some contours. Highland is located in Albemarle County, Virginia. That's near Charlottesville. And what we're going to do is we're going to take a look at some of the raster that surrounds Highland. When we go ahead and drop in our study area, that's going to be our parcel. There actually are two parcels to this data. When you're looking at Highland, there is the main portion, and then William & Mary also has a smaller portion here, but our study area is going to be the main part of Highland. So with this, what we're going to do is we are going to go in and we are going to, we're going to take a look at a DEM. We're going to add that in. We're going to add our you'll see that it's a little bit larger, and that's a digital elevation model. It's a little larger than our study area. I'm going to go ahead and add the DSM and the DTM as well. So remembering that we have a DEM, which is the basic values of the digital elevation model. These have been derived from a LiDAR data set. The DSM is the digital surface model, and the DTM is the digital terrain model. So remembering that as we take a look at these, we're looking at the terrain as being what is on the, let's take a look at this. So I've moved an image over to remind us visually of what the difference between the DSM and the DTM are. So the digital surface model is everything that is on the surface. So trees, the ground, if there's no obstructions from above, buildings, whereas the digital terrain model is just that. It is the terrain at that bare earth level. And so that's without any objects. When we're taking a look at this, we have our terrain model and our surface model here. if we want to think about it, which is on top versus which is kind of at ground level, you might want to change your order to have the DSM and the DTM in those orders. I'm going to go ahead and just kind of close up the DEM for just a moment. Now, one of the things that we often will want to take a look at when we're looking at our imagery is we may want to take a look at what the basic properties are. So I'm going to turn on just the DEM, and I'm going to right click on it, and I'm going to go to properties. And in my properties, obviously, I can rename it when I want to make a layout with it. But more importantly, as we go down through this, is looking at the data source information. Now, notice that this data type is a raster. In this case, it is the Highland DEM. It is in US feet. That's not in meters. As we look at the spatial reference, we are going to find that it is already projected into a local projection. And so that is a state plane projection, which puts us into feet. Inside of the raster information, we actually can glean quite a bit of information. The first thing is how many rows and columns. Remember, these are gridded cells across the image, and how many bands as well. Our cell size is 10 by 10. In this case, our X and Y are 10 by 10. Remember that we are in feet, so that's 10 by 10 feet. The uncompressed size, so one of the things that happens when this is in storage is that it's compressed, and when the program begins to use it, it uncompresses it. In this case, it's a 2.17 megabyte file. It's got its formatting information. There's information in its statistics. In this case, it has one band, and in that band, the values are from 421 to 961. So this information is talking about an elevation model. So therefore, these values are that elevation. So that's just a little bit about how to find out the information about the data. There is another piece that we want to take a look at in our Highland demo folder, and that is our land use land cover. It actually is our land cover data. And we're going to add it. It comes in gridded cells. And we are going to load this particular data into our map. And we're going to take a look at it. We're not going to hit the geoprocessing. That's not what we meant to do. I right clicked. I'm just going to drag and drop this on. And you'll notice that this particular data, when it enters, it is still a raster. We're going to take a look at its properties. But under general, under name, what I'm going to do is I'm going to change this to land cover so that we all know what we're talking about, that this is land cover data. In this one, when we take a look at its properties, we can tell that in its source information, it too is in US foot. The raster has a lot more columns and rows that are taking place here. And its cell size is 3 by 3 in feet. So that means that we have a differentiation between our 10-foot data and our 3-foot data. And that's something that we're going to have to account for as we're working through this process. The other interesting thing about this, if you look at something like a DEM or a DTM, you'll notice that the digital elevation model, because it's continuous data, the continuous data always will have the cell will represent that elevation, or if this was precipitation, it would represent that measurement of precipitation. So this does not have an attribute table because the value inside of each cell is what it is. It's a value. In land cover, it's a little bit different. Notice that we have these numbers that are here, and these are representative of the USGS categories that are used for land cover. And in the land cover, notice that we do have an attribute table. This is known as a VAT, V-A-T, value attribute table. And the value attribute table for the land cover is going to give us our value and then account for that particular value. And that will come in handy as we're taking a look at it a little bit later. So I'm gonna close this for right now, but just wanted to make sure that everyone understood that piece. When you're working through the lab, one of the things that you're going to do is you're going to look at a table that's going to tell you that 11 is going to be water. And you're going to actually reclassify this data. And we'll do this in this example as well. So this is just an introduction to the data that is part of this demo.